Hi, I'm the third undergraduate student from Cal Poly, and I would like to talk to you about a open source robotics applications interface. My apologies.
Oh, sorry,
We got skipped over a bit. Yeah.
It's just the one.
There you go.
Ah,
Thank you.
Yeah. Awesome. Okay.
Perfect. So the key motivation behind this is that robotics and autonomous systems are at the core of many industries, emerging applications today, and the variety of peripherals in general in robotics applications is so diverse that it makes it challenging for a custom set of peripheral controllers to be integrated into an SoC. Kind of do it one by one. So what the goal of this project is to create a system interface and a standard template for building SoCs for robotics applications. Specifically facilitate the integration of standard and custom I/O. If we look at, so there are some of the features are specialized robotics peripheral controllers such as the stepper motor driver, the quadratron encoder manager, and it has the standard peripheral controllers like SPI master, I2C master, UART bidirectional GPIO, and PWM. This interface allows for a configurable quantity of peripheral controllers, and it's the individual parameters that define these controllers are also parameterized. From an architectural overview, the key component here is the peripheral control register file. Basically one block having all the control registers that you would need for the corresponding modules that are directly connected to it. There's a pin box that interfaces with between the inputs, outputs of the modules with the I/O pins of the chip. And there's interrupt-based transaction completion detection, so there's a dedicated system interrupt included. This design is intended to be like an encapsulation and a configurable entity that would include, so it's generator-based, open source IP blocks, and it's extendable, fairly easily extendable to include any other peripheral controls that you want. But the nice thing about this is that you have one point of access between the CPU and your peripherals, whatever that may be, which makes overall SoC design simple and faster. I would like to give a little bit more attention to the stepper driver controller because usually this is a software programmed entity. This simple interface allows the user, the designer, to just provide the number of steps, the maximum speed wanted to attain in the motion of the motor, the acceleration and the jerk, and the output is the actual pulses for the stepper controller motor following an S-curve motion model. So modules like these allow for real-time operations being offloaded from the CPU to dedicated hardware modules. So that increases overall system performance, which is important for real-time applications. And that's pretty much it for this interface. Please let me know if you have any questions.
Thank you.
Going down?
Down, yeah.